Good morning, everyone. I know I'm a few minutes early, but I don't want to. I accidentally clicked it early, so I don't want to end it because I don't want to confuse everybody. So, if anybody's here early and you have questions, we can get started. If not, I'm just going to read about the NFL draft on my phone. Or let me officially. All right, 8:30. So if you are out there listening, can you watch? Let me see. Good morning from. All right, if you're out there listening, let me know who you are and where you're listening from. And let's get started. Nice, nice. Doucement. Deville. St. Martinville, Ville Platte, Abbeville, Coupe de Ville. All right, guys, who wants to break the ice? Abbeville. Who wants to break the ice with a question? Remember, this is more to clarify content, not. I'm not gonna go into will this be on, will that be on. I haven't written it yet, but if we talked about it, it can be on. Hey, Charlotte, Kirby, Peyton, Kelly, and Charlotte. Who else we got? So if you have a question, a clarifying question, feel free to go ahead and kick it off. Oh, oh, oh. What do y'all want to talk about? Saints draft? No. Kirby, for whatever reason, I thought about like my wife and I started watching the Tiger King last night. So like I thought of you like having just this big like exotic like big Tiger King setup watching the YouTube live stream. That just kind of made me chuckle. What a crazy show. Are only in 2 episodes and it's like they must be from my my neck of the woods, man. I'm not a fan of that lady. What's her name? Carol. Whatever. She seems like I know she tries to come across as the normal, but I think she's like the most weird one. Although the harem guys, that's kind of creepy. All right, guys, what y'all want to talk about? Carol Baskin. That's it. Yeah, she's like the weirdest one, but I don't know. I could be off. We could go over the biomechanics of Tiger King. See if I can make it reach across the room. All right, guys, what do you want to talk about? La 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 la. Come on, guys. If y'all don't have any questions, man, it's hurting my back anyway. Ugh, getting old. My wife asked me the other day, she's like, what was wrong? I was like, dude, my joints, man. Ugh. My joints are aching. The bird's looking at me. Let's see if I could do it. Let's see. Let's see. Let's see. Let's see. How's that? Orange bird. Say hello, orange bird. Carol Baskin killed her husband. She fed him to the tigers. That's what I heard. They're great. I know some of you know that I do a lot of fundraising and auctions and stuff for people. I wonder if a Joe Exotic autograph would auction off. Like if people would want that. We'd probably have to disinfect it first. Dude, I've been finding the best memes. Anybody else have a meme addiction? All right, guys, any questions? I'm reading about Chris Pratt and Anna Faris's breakup, the reason behind their breakup. Let's see, are you... Okay, so I got a text from someone who wasn't able to log in, and they want, can you give more examples of second-class levers? So in the body, in biomechanics, you can look at any force. You can look at any force and its leverage. So what I mean by that is, let's say I have this pencil and I have a force on this end pulling down. Let's say the axis is about right here on my knuckles, because if I bent it right, it would kind of snap somewhere around there. And then I have another force pushing down on this end. So this is my left hand, this is my right hand. So I'm going to say left force, right force. So the left force has a second class type of advantage, meaning that perpendicular distance, even though, what's the word I'm looking for? Even though there's technically three types of levers, it's all about the advantages. So like third class is another way you could look at it is the advantage will be speed. Second class is the advantage will be torque. Those are advantages that naturally come with those levers. First can be any four depending on the axis. So my point is that you can look at this finger producing a second class type of advantage, and the opposite on my right hand is a third class advantage. Torque for lack of speed, speed for lack of torque. So think about if you have like a weight way out there, the weight in your hand, let's say I had a weight in my hand, that would be a second class type of advantage because it's very far away. It's got to travel a long distance. But if I drop the weight, my arm would swing back up real fast because my muscles have more of a third as compared to the second of the weight being so far away. So, so second-class muscle advantages in the body are muscles that insert very far away from the axis when using open chain things. So, biceps brachii at the shoulder crosses the shoulder early and inserts very far away. So it has more of a second-class function in the sagittal and frontal planes. Transverse, they're all thirds because with the transverse being in the long bones polar axis, all the muscles, no matter how they insert, are the same distance from the axis of rotation. What I mean by that is if we're looking at a long bone and the axis of rotation here, it doesn't matter if a muscle is inserting close, middle, far away, it's the same perpendicular distance from the polar axis. So that's why things that spin about the long axis, they're all thirds, they're all speed. And you think about it, you need a spin about the polar axis to throw things fast. So all muscles in the transverse plane of the joint are speed functioning third classers. Because they insert very close to the axis about the polar axis. But when we're talking about the frontal and the sagittal, now far away, increase in torque at decrease in speed, closer to increase in speed, decrease in torque. So, so examples of seconds in the body, are muscles that insert far away. A example of looking at a whole system would be like at your ankle, but not at your ankle joint. You have to look at the whole foot. What I mean by that is your plantar flexors, think of a wheelbarrow. The classic mechanical example of a second class is a wheelbarrow. Pulling very far away, here's the axis at the wheel. Here is your force pulling up on the handle. The resistance is the weight in the wheelbarrow, right? Your body has something similar where your ankle joint is actually where your hands rotate about the handle of the wheelbarrow. Resistance would be your body weight. And then the axis of the wheel would actually be your metatarsal phalangeal joints, your toes. So in other words, your toe is the hinge, and your foot is the handle, your weight is the resistance. And the rotation that occurs between your hands and the handle, think about it, when you lift up a wheelbarrow, there's some rotation that occurs there. That's your ankle joint, that's your talocrural joint. So the point is that when other people use mechanical examples for biomechanical purposes, we have to take in all the different pieces. We can't say the ankle joint is like a wheelbarrow. Oh, the ankle joint is like the hands on the handle of a wheelbarrow. And the toes, the metatarsal phalangeals, is like the wheel of the wheelbarrow, and the foot is like the wheelbarrow itself. So you have to put all the different pieces to make it actually make sense. Same thing for like a push-up. If you say, the push-up is like a wheelbarrow, well, you got to define all the different parts and say, well, the force from the ground up here, far away from the toes, and the resistance in the middle. And so you have to look at it holistically. But intrinsically, when we look at specific muscles, if they insert close to the axes and open chain, they're going to have advantage of speed with a disadvantage of torque. If they insert further away, they're going to get more advantage of torque at a disadvantage of speed. And like I said in the lecture, speed muscles can choose to work slow, but slow, strong muscles can't choose to go fast. So you think about like a big muscle-bound person probably isn't the fastest person in the world sprinting, but a sprinter, even though they may not contribute as much as the big power person, can choose to contribute to something that's a big heavy load, because that big heavy load will not be done fast. So speed muscles can contribute to max force production, but big max force production muscles can't contribute to going fast. So throwing and kicking and trying to go as fast as you can, those are going to be specifically speed muscles. The one exception is the polar axis and the transverse plane, because all muscles that insert all down the line, far or close to, have the same perpendicular distance to the axis of rotation in the transverse plane. So that's why like biceps inserts far away, so it's a second at the shoulder in terms of sagittal and frontal, but it's still a third in terms of internal and external rotation. So thank you for that question, Bailey. I hope that clarifies it. So it's really about just understanding, for the purposes of the test, I could give you like very specific, obvious questions, like the rectus femoris at the hip would be more second or more third. The iliopsoas would be more third. I hinted at these in class. I didn't tell you the classification, but I said, notice how this would be a lot more for speed, and inserting far away would be great for brakes, slowing down motion. So, or just the advantage, right? Thirds, speed. Seconds, torque. What's the advantage of torque? You can apply your force. You can optimize your force with a greater perpendicular distance, more torque for your given force at the expense of speed. So in class, I gave let's see if I have my little notebook out here. There it is. I had a little binder that I used on one of the lectures to say, let's pretend that I gave a 1 pound force. Well, if I applied that force very close, I'm not going to open up the book. But as I go further and further and further out, my 1 pound force gets amplified by the perpendicular distance. And I can open up the book with that 1 pound force. The advantage of that force, going further out, amplifies the rotational influence. Now, the negative is that this 1 pound force is going to move it, but it's going to move it relatively slow. I got to travel a great arc distance to open it up. If I apply a significant torque very close to the axis, I could open it up real fast because this force that's happening way close to the axis only has to go from here to there. Look at that short arc distance. And it's going to get a sweeping range of motion distally. So A to B versus A to B. My thumb had to travel all of this versus traveling all of that. Okay. So again, it's about understanding the basics of levers, leverage concepts, gaining advantages and disadvantages. When you need speed, you're going to use first classes that have an advantage of speed and third classes, because third classes always have the advantage of speed. When you're dealing with amplification of forces, emphasis of force, torque, you're going to emphasize firsts that have the advantage of torque. Those are going to be our major ones. But then also anything else can help if we're trying to do a max force on anything. Now, the thirds and the firsts that favor speed, I'm not saying they're going to be significant contributors, but all hands on deck. When you're trying to generate as much force as possible, you're going to recruit any lever from any muscle that can contribute even a little bit of influence, any bit of force. Balance, we're looking at firsts. First classes favor balance. So balancing on your foot, balancing on your hip, balancing on 2 feet, your flexors and your extensors, with your hip being the axis in the middle. So if you think about standing up and your hip axis, your bilateral axis here, and your hip flexors and your hip extensors and your resistance, and they're going to be working to balance. Your ab and adductors, your left hip ab and your right hip ad. So there are first class lever arrangements all over the body. It's all in how you define all the different forces and all the different axes. It could even be your center of mass. That could be an axis. But the key thing is that even though that's a lot of information, it isn't, because it's about what do you need? Do you need balance? First classes. Do you need speed? Third classes, and first classes favor speed. Do you need a ton of force? Second classes are going to provide most of it. First classes that give the advantage of torque are going to provide most of it. And anything else you got can supply some of it. Redirection of an applied force, I talked about that in first classes. How here's your hip, here's your axis, and if I bend over, hamstrings pulling down makes the front of my body go up. Hamstrings pulling down makes this end of the teeter-totter go up. I gave you the example about the cervical as well, right? Pulling on cervical extensors down on the back makes the front part of my head go up. It redirects an applied force. That's a function of a simple machine. That's a function of a lever. I pull down on this end and the other end goes up. It's a first class. Yeah. You could even look at it. It's not as easy here. So you got to see it was a true axis in between multiple forces playing teeter-totter. Okay. So did that help? It's all about what you need. And your body is going to incorporate leverage for what you need. And again, there's a lot of different leverages. You can leverage within your body, and then you can supply that leverage to levers outside of your body. You know, the wheelbarrow is itself has the potential to be a lever, right? So here's the wheelbarrow axis, and I'm going to pull far away so that I can handle a large load. Resistance, axis, force. But there's rotation in my hands and the handle. That's what your ankle joint is when you go up on your toes. The gastrocnemius and the soleus, the big powerful plantar flexors, they are my hands. The rotation between my hands and the handle, that's your ankle. And the wheel is your toe joint, your metatarsophalangeal joint. Okay, so going up on your toes is like a wheelbarrow, but the ankle joint is not like a wheelbarrow. The ankle joint, the talocrural joint, is specifically your hands on the handle of the wheelbarrow. That's your ankle joint. The wheel part axis is your toe, is your metatarsophalangeal joint. All right, I haven't gotten any comments. Was that helpful? Was that good? Was that bad? Help me out, guys. Yay. I don't know if you went back to bed, Kirby. I like orange bird. Orange bird's cool. Smells like Disney World. So again, keywords. Keywords on the test. If I say first class, what's a function of first class? First class can favor all four functions of a simple machine, but not all at the same time, because you can't have speed and torque. You can't have the second class and the third class function at the same time. So traditionally, we look at speed as the third class advantage, and we look at torque as the second class advantage. And I told you why, because in the third class arrangement, the resistance, the other force, will always be further away than the muscle force. So therefore, the muscle force will always be closer to the axis, therefore have the advantage in speed. And the opposite for second, the muscle force will always be further away, therefore always have the advantage in torque. But it is a continuum. It's a continuum. Some people, let's go with the elbow, for example. Let's say some people might have their bicep insert closer to the elbow than other people. I'm not talking like way over here, but a little bit gets amplified. So if your bicep has a little bit further away insertion, you're going to have more advantage in torque, but the one who has it insert a little closer is going to have more of a biomechanical advantage in speed. Okay, brachioradialis. On the test, if I said, what leverage advantage would the brachioradialis have in open chain? You'd say, well, look how far away it inserts. And the brachioradialis would have an advantage in torque with a disadvantage in speed. Biceps brachii, brachialis, advantage in speed with a disadvantage in torque. That kind of stuff. So that's why, this is exactly why you can't say the elbow is a third class, because it doesn't take into account which muscle you're talking about. If it's the elbow and the bicep, yeah, third. But if it's the elbow and the brachioradialis, the second. It's muscle dependent for when you're talking about levers in the body. We don't look at levers in the body as just the joint. We don't say the ankle is a. We don't say the elbow is a. We don't say the shoulder is a. We have to define all the different pieces and say the shoulder, when we look at this particular muscle, this particular resistance. So in biomechanics, we're a lot more into muscles. This is a classification of a muscle as it pertains to the axis or the joint that it's working in. And all of these have to be looked at in open chain, because when you get into closed chain, a lot of things change. Muscles pulling on bone, bone pushing into joints, leverage from the patella pushing into the knee to the hip. That's a lever. That's leverage. The patella pushing into the knee to the ankle. That's leverage. So there's just so many different ways to look at it. My job isn't to have you guys master all of that stuff. It's way too much. It's to introduce you to the concepts of leverage, functions of a simple machine, advantages and disadvantages. And then when you guys go off into graduate school, having those basic tools, then you can apply it to a vast array of different biomechanical systems. So again, if anything, I just want to make sure you guys understand that that's why we don't say like the ankle is a, the elbow is a, the knee is a. You have to be more specific. Which muscle are we talking about? Or muscles, the same muscle could have different leverage advantages and disadvantages at different joints. So take the rectus femoris. It's a hip and knee crosser. In open chain at the hip, it has second class advantage. But at the knee, it has third class advantage. It inserts very far away relative to the hip, but it inserts very close to relative to the knee. So second class at the hip, third class at the knee. All right, guys, last call for questions. My back's starting to be stiff. As per the email, your test Wednesday is going to be at 8:30 to 9:20. So it's going to be in our regular class. Kirby, you can take it from your bed, but you got to be up and ready to take it at 8:30. Okay, guys? We're going to try to keep it as similar to class as we can in terms of time and stuff. But the questions are going to just be short, sweet, straightforward. Functions of this muscle, functions of that muscle. Also, I will not have none of these as yay. I will not have none of these as an option. Okay, so it's going to probably be 4 answer multiple choice. Maybe a couple true false when I can't come up with 4 answers. Okay, last call. Anything else? You guys have my cell. If we need a FaceTime or talk or clarify, just text me first, because if you call me, I'm going to assume you are trying to reach me about my about an extended warranty on my car, and I don't like to answer those kind of questions, those phone calls. So text me first. Let me know who you are, and let me know that you want to chat about school, and we'll FaceTime, or we can set up a Zoom, or we can set up whatever. But know that I'm here to help clarify. Even on the weekends, I'm going to be available for you guys. Okay. So y'all have a good day.